Okay. All right. So for our next section, we're going to be talking about different properties of trapezoids. Okay. And you don't have to obviously memorize the fact that this is theorem 6.21 or this is theorem 6.22. You just have to be able to apply what the theorems are saying. So 6.21 and 6.22 are connected because 22 is the converse of 21. Okay. So what 21 is saying is if a trapezoid is isosceles, then both pairs of base angles are congruent. Okay. So I think the best place to start here is to draw a picture. So we're going to start by drawing an isosceles trapezoid. Okay. And what I actually want us to do for this picture is I want us to go ahead and label the vertices. All right. So going around here, we're going to label this A, B, C, D. And then because of discussion purposes on this set, we're going to copy and paste this and put it into the next three pictures, if it fits. I'll make mine a little bit smaller. Okay. All right, so to start here, all right, we know that this is isosceles. So I'm going to state that AB is congruent to CD, obviously, okay? So then what this theorem is saying is that if we know it's isosceles, then we know that both pairs of base angles are congruent. So in this picture, AD and BC are our bases, okay? So our base angles are going to be the angles along those. So angle A and angle D are a pair of base angles, which means that angle A has to be congruent to angle D. All right, same idea. All right, B and C are a pair of base angles, which means that B is congruent to angle C. All right, that's what this theorem is saying. We would know, though, all right, about A and B is that they would still have to be supplementary, all right, and same with C and D would also have to be supplementary because they're same side interior angles. Now, 6.22 is the converse of this, okay, which means that this time, if I'm given that angle A is congruent to angle D and B is congruent to angle C, this is our given information. The conclusion then is that AB is congruent to CD, all right, that it's isosceles. All right. Now the last one is if a trapezoid is isosceles, all right, then the diagonals are congruent. So if I drew the diagonals in connecting B and D with C and A, okay, these two segments of AC and BD have to be congruent, all right? So AC has to be congruent to BD, all right? What we don't know is that the intersection, all right, bisects those diagonals. So we don't know, all right, that if this was E, we don't know BE is congruent to ED. That's not true, all right? We don't know that diagonals bisect. All we know is that the diagonals are congruent, okay? All right, so we're going to apply it from this point on. And I'm going to start with example 3. So example 3 says you have isosceles trapezoid EFGH. Find the missing angle measures, okay? So we are going to be given then that EH is congruent to FG, and then our base angle, or our bases are EF and HG, okay? And we are given that angle H is 75 degrees. So because we know it's isosceles, what do we know about the base angles, all right, of that isosceles trapezoid? Well, we know that they're congruent. So that means that angle H has to be congruent to angle G, which means that angle G is also 75 degrees. Okay, so angle G is also 75. So then how does that help us? Like, how can we then go and get E and F? Well, what type of angles are H and E? All right, they're same side interior, which means that they're supplementary, which means that you would do 180 minus 75 in order to get that the missing angle E is 105 degrees. And because E and F are base angles, all right, what do we know about those if it's isosceles? Well, we know that they have to be congruent, which means that angle F is also 105 degrees. Okay? All right, let's try. Sorry, guys, I'm trying to pull my answer key real quick. Okay, let's try the next one. So let's look at example 4, and I think we should draw this trapezoid. All right, so let's draw trapezoid. FGHJ, All right, so start down here. F, G, H, J. Okay. And let's go ahead and draw in our intersection or our diagonals. And we're going to go ahead and state that that intersection point is K. All right, so that's the picture that you should have for us. I'll give you a second to make sure that you can draw it. Okay, so what this question is saying is that this entire angle right here of angle FJH, all right, so this full angle is 85 degrees. Okay, that's what that's saying. It's saying that FK is 8, so this entire segment is 8. All right, but then it's saying that this full segment of GJ, all right, is 19. So I don't know exactly how we're going to write that in there, all right, but that full segment is 19, okay? We're also given that it's an isosceles trapezoid, which means that this segment has to be congruent to this segment. Okay, so from here, we need to find what angle FGH is, and then we have to find what KH is, okay? And it's not drawn to scale, but let's go ahead and realize that it's isosceles trapezoid, and that's going to tell us a lot of information. What that's going to tell us is that our base angles are congruent, which means that this angle of J has to be congruent to this angle of F, okay? So if angle J is 85 degrees, what does that mean about F? It is also 85 degrees, okay? Which means then that angle F and angle G, all right, have to be same side interior angles, which means that they have to be supplementary. So to find angle FGH or angle G, all right, you're just going to do 180 minus 95, which means that that angle is 95 degrees. Okay? Now, on our next one, it's not drawn to scale, okay? But what do we know about the diagonals of an isosceles trapezoid? Well, what we know is that they're congruent. So if you know that this full segment, all right, of GJ is 19, and then GJ has to be congruent, all right, to FH, right? Because the diagonals are congruent. So if a portion of FH is 8, what does that mean that the rest of the portion has to be? Well, to do that, you're just going to do 19 minus 8. And so that segment right there is just going to have a length of 11. And like I said, it's not going to be drawn to scale. Okay? All right. Let's do this one right here. And then I'll pause and then we'll come back for more vocab. So in example 4, all right, this is once again coordinate geometry. And so what we're trying to determine is if these vertices make a trapezoid, and if it is a trapezoid, is it isosceles, okay? So what I'm going to do is I'm going to go ahead and just quickly sketch out a trapezoid, all right? And I'm going to label the vertices just so I can picture what my sides are and what my diagonals are, all right? So I'm going to start down here and just do A, B, C, D. Now, the way that I drew it was that B, C, and AD are the bases, all right? That's not necessarily true, all right? That's just how I labeled it, okay? So really, B could be the base and same with CD, okay? It's just how I sketch it. We're just trying to visualize. So what would we do here in order to determine if it is a trapezoid? Well, what's the definition? The definition is that it has to have exactly one pair of parallel sides, right? And so how does that help us when we're given these vertices? Well, if we found the slope of each of those sides, we're looking for exactly one pair that has the same, okay? So like I did before, I'm not going to work out this entire question, all right? I'm at least going to give you the answers. But we're finding the slope of AB. All right, we're going to find the slope of BC. We're going to find the slope of CD. And then we're going to find the slope of AD. Okay, so we're finding the slope of all those. And we're looking for exactly one pair that has the same. Okay, so if you found the slope of AB is 1/5. Okay, the slope of BC is -2. The slope of CD is 3/4. And then the slope of AD is -2. All right. So if I'm looking at all those slopes, what I'm focusing on real quick is this right here, -2, -2, which means that that one set is parallel. all right? And just by coincidence with the way that I drew it, all right, BC and AD are the bases, okay? So it is a trapezoid. We know, yes, it is a trapezoid, all right, because you only have one set of parallel sides. If you had both sets of parallel sides, all right, then it would be a parallelogram. If you had no sets of parallel sides, then it would just not be a trapezoid. It would be a quadrilateral. So what would we do now to determine if it's isosceles? Well, to make it isosceles, we would want to know if this side length of AB is congruent to this side length of CD, right? So what we're going to do now is we're going to find the distance of AB and of CD. Okay, so we're going to find the distance of those two segments. Okay, so to do that, all right, you're going to use your distance formula. All right, so if you would work through this, all right, for AB, you're going to get the square root of 26. And then for CD, all right, you're going to get the square root of 25. All right. And so from there, we can see that they're not, which is 5. I understand that. All right. But either way, all right, we're going to see that they're not congruent, which means that this quadrilateral is a trapezoid. So it is a trapezoid, but it's not isosceles. If they matched, if those two distances matched, then it would be isosceles. All right, but this is our final answer. Okay? All right, I'm going to pause there and then come back for the rest of that vocab.